In Module 6, we will finish Chapter 4, continue to talk about data addressing and other arithmetic instruction. In Tuesday and Thursday lecture, we will talk about indirect addressing to see how to access the operand from the label array. And we will talk about two other instructions, jump and loop. And also we will compare 64-bit programming. So the first one, let's talk about indirect addressing. So when we talk about indirect addressing, we will see what is the indirect operand. We were using sum of array, for example. So the first thing before we talk about indirect operand, I want to remind you some data-related operator from we talked about end of last week. We have offset operator, PTR operator, type, length of, size of operator. Those operators can help us to access the indirect operand. So the indirect operand, that means you have a data label, but continue with multiple data you can access. So the first thing, let's remind you what is the offset. So the offset actually returns the distance in bytes from the segment. So that means here, if you remember, if we have multiple variables defined here, we have a byte variable, word variable, and a dword variable. If we want to know where their location it is, because remember, when you're just using the v-val, they will automatically dereference. They will automatically dereference to access the value. So even here, the value, we just don't initialize that. We're using the current location value. But one thing is, if you only access using the data label, they will automatically dereference, access the data. So if you want to only know the location for those variables, we can use offset. So when you use the offset, remember in 32-bit environment, any memory location we will access in the 4-byte. So that's why here we have the one general purpose 4-byte ESI to save the value. So that's why your ESI will be changed according to the location. So the offset just like to give you the memory address. So then we also talk about the type operator. So the type operator returns the size in byte for a single element of one data declaration. So you need to always remember your data here, val1, val2, val3, val4, those data declaration is associated with this label. So you're just using the type val1, they will know that's bytes, so they will return 1. So then you have different types, so they will return different value. Then you will save in the location to know the number as a byte. So that's a type operator. So if sometimes you know one data label, you can using the type operator to know their memory size in byte. So then we have length of operator. So the length of operator counts the number of elements in one single data declaration. So for example, you can see here, byte 1 is the data label. Data type is byte. So I declare 10, 20, 30 for the value. So that's why if I using the length of, they will have 1, 2, 3 elements. So then array 1 is word data type. So here remember you have the DUP operator. So they will repeat 30 times for the value not initialized. So that's 30, 1, 2. Total we have 32 elements. So then you have array 2. The same thing, they are words. So here you have 5 DOP. But the DOP inside they have another DOP. So they want you to do 5 times. Each time have 3 elements, not initialize the value. So 3 times 5, array 2 will have 15 elements. So then you can see the last one, the string byte. So you will see here, because the data type is byte, right? So even that string, so we will consider they are byte array. So you see 1 byte, 2 byte, 3 byte, 4 byte, 5, 6, 7, 8. And don't forget your no character will count as well. So that will be have 9 elements. So that's the length of. So the length of actually just return you the number of the element from the data label. Sometimes length of and the size of you were a little confused about that. The size of operator actually return a value that is equivalent to the total size. So that would be the length of how many elements times what is the type of each one. So that's why you can see byte 1 we have 3 bytes. So total size of is 3. So here for the array 1 word, earlier we say for length of we have 32. So 32 times 2 each byte. So then size of will be 64 byte. So array 2, the same thing, you have word. So 5 times 3, you have 15 elements. So times each one is 2. So total you are 30 in the size of. So that will be the difference between the size of and the length of. So those operators is very important when we're moving forward to the next topic. We talk about the indirect operand. And we will also calculate the array of the sum of the array. That we will all use that. So an indirect operand, that means they hold the address of a variable. Usually is an array or a string. They can be the reference to access the data. So what is the indirect operand? So we see, for example, here you have your val1 defined byte. So then we have 3 elements. So indirect operand means you're only using the memory location to save in that register, then using that register to access the data. So we see here, for example, we have the val1, right? So the val1 actually look like here. So that's beginning for the val1. So you have 10, 20, 30. So now, like earlier we say, we can save the val1 location using the offset, right? So that's how they look like. Okay, val1 actually refer to that location. So now we save that in ESI. So actually ESI location is, for example, we say the location for val1 is 10200. Okay, so then that value for the memory address will be saved in ESI. So ESI itself only holding the memory location. But can I using the ESI to access the 10? Yeah, we can. So that's why this one, when you want to using the pure memory address to access the data, before we say if you're using the data label, your square bracket is optional. But here, if you're using the ESI only holding the memory location, then you want to using the ESI to access the location data being saved. So then you need to using the square bracket by requirement. Also, we require you to using this square bracket. Otherwise, if without square bracket, ESI itself is 4 bytes. So that's why they are only holding the memory location number. So now here, after you do the ESI, right? So your ESI using the square bracket to dereference. So then you want to read only 1 byte. So then you just move to AL. So then from this location, they read 1 byte. So 10H will save in AL. So continue. ESI, if I increment ESI, right, I increment ESI, ESI actually is holding the memory location. So I increment by 1, they add by 1 byte. So that's why ESI can refer to here. So then depends on how you want to dereference the value. So if you want to only read 1 byte and dereference, so you see here we have the square bracket. So now they will read as 20 and save in AL. So then the same thing, next one, ESI will move to the next one. So then you move to AL. So they will have 30 saved there. So that's what we call the indirect operand. Indirect operand means that operand only save the memory location. So in order to read the data, we need to do the dereference using the square bracket. So after you understand the indirect operand, so we see one more example. So the indirect operand, if you want to increment here, right? Also, you need to be careful. You increment, ESI is increment the memory operand value in the ESI. So sometimes you need to be careful. If you want to increment the location value, then will be different. So we see here. So how to increment the value stored by count using the indirect operand. So indirect operand, that means I save that location to a register or the 4-byte location. So then we will see here, my count is the word data type. So then value is 0. So then I save my count location offset to ESI. So now you want to increment my count value using the ESI location. So before you say, oh, okay, I want to increment this one, right? I'm using the ESI dereference. So then I increment that value. But here you need to be careful. That one actually is wrong. Why they are wrong? Because you see here, they are ambiguous. Why? Because you only have ESI to using the square bracket to dereference. So that means I go to that location, I read, but I don't know how many bytes I need to read. So that's why they cannot increment that value. So instead, you need to using the ESI dereference, but we add the PTR. So this PTR tell from this location how many bytes I want to read. So since my count is word, so I do the word PTR. So I read 2 bytes, then I increment by that. Okay, we see that's how they look like in the memory location. So my count, right, you can direct automatically dereference to 0. But ESI actually is only holding the location. So that's why when you're using the ESI, I know I point to here, but how many bytes actually they don't have information. My count come here, they know they read 2 bytes. That's because this my count label followed by the definition say words. So every time when access this location, they will read 2 bytes. But ESI is totally only have the memory location. So whenever you do the dereference, right, they don't know how many bytes they need to read. So that's why if you do like this way to increment, they don't know they need to read 2 bytes, they increment by 1. So instead, if you're using the indirect addressing operand to do the increment, or because you only have 1 operand, so then you need to tell them how many bytes to read. Okay. So before this one, they don't have the issue. That's because when you do the move, I move ESI value to AL. They will according to the AL is 1 byte. So from ESI, they read 1 byte. So on the other hand, when you're using the indirect operand, they need some other operand to release the information about how many bytes we want to read. So for the move or add or sub operator instruction, because they have the other variable or register knowing the number of bytes they need to read. But sometimes like increment only have 1 operand. So you're only using the ESI, they have no idea how many bytes you need to read. So then the same thing, like this one. Should we use the PTR for this one? Yeah, because when you add ESI by 20, right? But 20 is what? 20 is a constant number, right? So that's why we don't know how many bytes from the ESI I need to read. So on the other hand, for this one, you do need to use the PTR to let them know how many bytes to read. Example like here. So we're using the word PTR, so we know we read 2 bytes from the ESI, so we add 20. So if just like this, we don't have enough information.